Hi folks, how you doing? So we're just going to look at this little topic called probability, but better for you, it's actually called basic probability. So, like they're saying here, probability is a chance that something is going to happen. Probability is really a prediction. We're not saying it's going to happen, it might happen. It's just based on um, other evidence that we might have. Okay, right. So here, the thing about probabilities for us, they lie in a range from 0 to 1. So here we go. There you go, 0 to 1. A lot of times they use fractions to represent them, where the top number is smaller than the bottom number, unless it's 1 over 1 with a equal. Right, so probability of 0 is something that's never going to happen. So hopefully you can come up with some example there of something that's never going to happen. And don't say you're going to pass this assessment. Okay. Anyway, we'll come up with some example. Right, at the other extreme on the right hand side, something with a probability of 1 is something that will definitely happen. So you can have a think about that. Oh, and some people might say, right, I'm definitely going to pass this assessment. Or someone's going to say, we're all going to die. I don't know about that. I don't know. I took a magic potion this morning that ensures that I'm not going to die. Or maybe not. Anyway, and anything else in between 0 and 1. We don't have negative probabilities. Well, not in this class, okay? Right. So let's get it all set up. Probability of an event. Right, that's a thing that's going to happen here. So just get the notation sorted out here. Probability that something's going to happen, well, we express it as a fraction. Okay, so favourable outcome, well, that's the things that you want to happen in your favour, as it says here. Right. Um, so who knows? Kind of the weather conditions. Is it going to snow? Is it going to rain? Is it going to be sunny? Is it going to be thunder and lightning? You might want one of those individual things to happen in your favour, maybe to be sunny. But all the others added together, they would be the total number of things that could happen. So total number of outcomes. So there's too many words there. So we're just going to shorten that. Okay. So probability of an event, I'll just put P in the brackets with an E in it. Inside that bracket, you can just use some notation, a letter, a symbol, whatever, for what you want to happen. The favourable outcome, the thing you want to happen over the total things that could possibly happen. Right, the sum of all the outcomes. Okay. Right, we're just going to dive into it here. Just give you a little example here. Two-sided coin. Um, so what we're seeing here is, oh, this coin here has got a head and a tail. I'm in the UK, so head and a tail. So we don't count in the edge, okay? But that could happen, but not in this class. So what is the probability that the coin lands heads up? Okay, so we're highlighting the important information here, and we're going to go for it. So there you go. That's my thumb, and I'm tossing a coin. So I'm waiting to see what happens. And what I want to happen is that it lands heads up. So let's go for it. So the probability of heads. So I'm putting P with that H in the bracket to represent heads. As long as the notation that you use there, if you're happy with it, that's fine. Then we're going to have a fraction here. So how many heads that was going do we have in the coin? That would go in the top. How many sides are we going to have of the coin? That would go in the bottom. Okay, so number of heads over number of sides. Right, so what have we got there? We started with a nice example here. You might not have a coin in your pocket, or your purse, or your wallet, or your handbag. But that's so how many heads? I'm sure you can manage that. One, yep. How many sides? Two. Okay. So 1 and 2, some of you are thinking, what? Some of you thought previously it was 50%. That's the same as a half, isn't it? So let's move on. So half, or you might have put 0.5. So that's a decimal approximation, or no, the exact decimal representation of 1 divided by 2, because that's what a half is. We didn't have to round it, so that would be fine. Okay, so we always start off with nice simple examples. Right. Oh, what would be the probability of a tail? And you want to know what? I've just noticed that. That's not a tail there, is it? No, that's not a tail. So I don't know what symbol would be in a tail. Something bizarre. Some kind of bizarre thing here. That's okay, isn't it? They always give you nice wee diagrams, so that's my wee diagram. Ooh, that's my tail. Okay, whatever that means. I'm not going to draw a thistle because I can't. Right, probability of a tail is... Oh, and see when I flip this, it's going to go back to the head on there. That's... Just bear with me. Okay, should have thought about this. So how many tails is there? Right, yeah, there's that head come back. That's fine, ignore it. Pretend it's a tail. How many tails is there? Number of tails, number of sides. 1 over 2, are you surprised? 0.5 again? I don't think you're surprised, are you? So, with the probability of head, probability of tail, 1 out of 2, 1 out of 2, right? And with 2 outcomes here, and we had the probabilities for each of them. And whatever the situation is, a scenario they're calling it here, all the outcomes or all the probabilities, they always add up to give you a certain number, and that is 1. It's always 1 regardless. So probability of head, probability of tail, half and half is 1. Do you agree? Aye, okay. I think that's fine. Right. What's that? What is that there? That's not a pizza. That is my kind of image of a dice, or maybe you're going to call it something else, a die. They call it a die, depends what language you speak. Call it dice. Doesn't matter. It doesn't, well, sorry, it might matter to you, it doesn't matter to me. Anyway, let's go through it. We need the ground rules here. 6 sides, numbers 1 to 6, that is 1, 2, 3, 4, 5, and 6. It's kind of 6 faces in it. I'm calling them sides here. Calling them faces. We're getting all geometric here. That's fine. So let's go for an example here. What's the probability of getting a 3 on a dice or a die face up? So that's important. So it's the number 3 we're looking for here. So we're going to get one little definition for probability. Probability of a 3. Okay, yep, we're just rolling it once. That's fine. That's what they're telling us here. So probability of a 3, P, in a bracket, put a wee 3 maybe. Let's get our wee definition here. The favourable outcome on the top things we want to have. We want a 3 over, well, the total number of faces. So let's see. So how many 3s do we have on our dice? And you're going to tell me there's only one, hopefully. Right, there is. And how many faces have we got? Total of 6. So probability of 3 is 1 over 6. Just leave it like that there. That fraction is irreducible. If you put 1 divided by 6, you would get something like 0.166666666. Leave it. Okay, we don't want that. And sometimes they refer to that saying you get a 1 in 6 chance of a 3 landing face up. Right, okay, let's move on. So this question here is, what's the probability, so prob is probability of getting an odd number face up when you roll a dice or a die just on the one occasion, only once, we're seeing here. So we need to figure, well, so if you're not sure what odd means, an odd number, just a little reminder, odd numbers, so what are odd numbers? Don't say strange numbers, because we have got a definition of strange numbers. So odd numbers, if you remember back from school, maybe you're saying 1, 3, 5, 7, 9, you just keep going, 11, just keep on adding to, there's a pattern here, right? That's what we're interested in. But we've only got 6 faces on our dice or die, so that means that only 1, 3, and 5 fit the bill. Okay, so we've got 1, 3, 5, so that's a total of 3 that are in our favour. We have 3 odd numbers that could possibly appear. So let's go back to the question. So the probability of throwing an odd number here, what we've got, favourable over total. So in our favour, we just seen there, it could be 1, 3 or 5, so that's 3 numbers, over our total of 6. And if you think 3 over 6 can get reduced as a fraction, then do so. 3 over 6, what do you think? Can it get reduced as a fraction? I think 3 can divide into the top, and 3 can divide into the bottom to give me 1 over 2, or a half, or 0.5. However you want to express it. That looks okay to me. Right. Okay. Let's move on. We're sticking with the die here. So this question here, I've not even put a question mark at the end of that. I should have done. What is the probability of getting a multiple of 3? So a multiple of 3, right? So maybe you're not sure what a multiple is. Well, that means 3 divides into it to give you a nice answer. Or I'm thinking about my 3 times table from school. And like I say, we're just rolling it on just the one occasion. So here we go for the 3 times table. Yes, you could have 0 times 3 to give you 0, right? Okay, but maybe 3 times 1, 3 times 2, 3 times 3. So you're getting 3, 6, 9, 12. Is there any more? 15, etc. Just keep going. But we've got a dice. It's only got 6 sides, 6 faces numbered 1 to 6. So do any of these work for us? What do you think? Any of these work for us? Yeah. 3 and 6 seem to work for us here. Or work for you. So that's 2 numbers that work, 2 faces that satisfy the requirements of being a multiple of 3. Okay. Right. So let's go back to the question. So the probability of being a multiple of 3, so I just write times 3. So just use some kind of notation that works for you. So our definition is a favourable things that work in your favour over the total number of faces, because it's a dice or a die. And we just saw there that with 3 and 6 being multiples of 3. And so we've got 2 of them, I hope. Over the total number of faces, again, is going to be 6. And if you think you can reduce 2 over 6. If that fraction can get reduced, then do so. Well, I think 2 divides into the top to give you 1, and 2 divides into the bottom to give you 3. So 1 over 3. That looks good to me. So that's just like a 1 in 3 chance of getting a multiple of 3 here. Right. Just remember, just with all these little videos, clips, you can always rewind them. That's the whole point here. So don't think, oh, he's going really fast here. I'm not. Just try to get the information down, and you can slow it down if you want as well. I'm sure there's a facility to do that. Right, okay, let's move on. So what they're saying here, a bag contains 12 coloured balls. Right, what's the scenario? 3 are red, 4 are green, and the remainder are blue. Right, okay, so we've got red, green, and blue. How many are blue? Right, so it looks as if you're going to have to do a little bit of arithmetic here to say how many are blue. You could take 3 are red, 4 are green, add them together to get 7, take them away from 12 to get 5. It's up to you how you do this. 12 take 7, 5. I think that works. Okay, so we'll get 3 red, 4 green, and 5 blue. Okay, there you go. Little picture here. So what do we want? What is the probability of choosing a red ball? Okay, without looking. Okay, without looking. Probability of choosing a red ball from the bag. Well, how many red balls is there? And what's the total number of balls in the bag here? So, probability of red, probability of R, favourable over total. So how many have we got? How many red have you got? Well, we said in the previous page that we had 4, and if you don't have a black and white TV and your colour perception is okay, I can see how many? 1, 2, 3. 3 out of a total of 12. Yep. And can you reduce that as a fraction? 3 over 12. Well, 3 goes into the top, 3 goes into the bottom. 1 over 4. That looks fine to me. And if you can get a decimal equivalent that you don't have to round up, that'd be fine. 0.25. Okay, let's stick with the balls. Right, or a 1 in 4 chance. Right, of selecting a red ball, and we just need to pull that down. There you go. I think that's fine for everyone. Okay. Right. Okay, though. Oh, it's giving us a blank page here. So what's the probability of choosing a green ball? And again, apologies, no question mark. Right. What's the probability that I'm going to leave out all the question marks here? What's the probability of choosing a green ball? Well, do you remember how many green balls you had? And out of the total? So let's see. Probability of green, favourable over total. So it looks like we're saying here, how many green balls you got? 1, 2, 3, 1, 2, 3, 4. 4 of a total of 12. Yep, and can you reduce that as a fraction? I think so. And 4 goes into the top, 4 goes into the bottom. That's the biggest number I can find to give you 1 over 3. Right. So that means you get a 1 in 3 chance of selecting a green ball from this bag here. Right. Oh, a little break here. Are we going to stick with the balls or are we going to move on? Let's see. Oh, we're going to move on. So, what does that look like to you? Well, maybe a selection of playing cards. Selecting from maybe a pack of cards or a deck of cards. Right, so just in case you don't know, I'm just going to go through the makeup of a deck of cards that I would use in Scotland. So that's where I'm based, which is kind of part of the UK, and I think they use these kind of cards all across the UK. And different countries use different types of cards. I'm just going to use the ones I'm familiar with, so that's why I'm laying out the ground rules here. Just like the coin, I told you it two sides, a head and a tail. Just like the dice or the die, 6 faces, numbered 1 through to 6. So I need to lay out the ground rules for the deck of cards here. So the deck of cards, they get 4 suits or 4 families or 4 types. So here we go. We got little symbols here. That one's called the hearts. Next one, that's called the diamonds. Next one, apologies for the drawings here. That's called the spades, I think. Yep. And the last one, they refer to that as clubs. Someone's made up these names, okay? So we just need to go along with it. Right. So we've got 4 families here, 4 types, or 4 suits. They use the word suits. Right. So within each of these suits or types or families, what we have is 13 cards in each. 13. So they consist of an A for like an ace, and then sometimes that's counted as a 1 or an 11. It just depends what kind of game you're playing. Then we've got a lot of numbered cards, 2 through to 10. Okay, and then we've got other cards called face cards, Jack, Queen, and King. So while we're here, I'm just going to bring up a set of notes that I've produced, just for those who are unfamiliar um, with the layout of a deck of cards. So I've just got it there. So up here, the top line's clubs, then I've got spades, then I've got hearts, then I've got diamonds. So you can see the layout there. So you get an ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then a jack, queen, king. And whatever jack means, whatever queen means, and whatever king means. So that's in case you're unfamiliar. So we've got 52 cards here. Right, so, but we're just going to move on here. So that's definitely 13, you can count them. Jack, Queen, King. Right, so that's 4 suits or 4 families, and within each we have 13 cards, so 4 lots of 13 to give you a total of 52. Okay with that? I think I'm okay with that. Right, but others may want to argue because they know there's 2 spare cards called jokers. So jokers are jesters, actually. Medieval clowns or current clowns, whatever. Sometimes they use these within card games, or they use them maybe as substitutes just in case you lose a card. But let's move on from that. Right. The most important thing for us here, that's the makeup we've got of the cards. Okay, ace, 2 up to 10, jack, queen, king, and we'll get our 4 families. Or suits. Right, okay, let's go for it. Just going to take that family, take that deck of cards, 52 with the 4 suits, 13 in each, and we're going to just pick a card at random from a deck of cards, and what's the probability that the card chosen would be an ace? Remember, you're not allowed to look here, no cheating. What's the probability that the card chosen would be an ace? Right, what's the probability that there would be an ace? Well, we need to think, well, how many aces is there within a pack of cards? I'll let you think upon that one. Alright, okay, so favourable over total. So, are you going for 4 aces? Maybe? 52 total. Can 4 over 52 be reduced? As a fraction, 4 into the top gives you 1, 4 into the bottom, 52 gives you 13. That looks good. I don't think it can get reduced any further. So that looks like there's a 1 in 13 chance of selecting an ace when you chose one card at random. Okay, let's stick with the cards. Let's go for it again. Let's go and pick another card. And what do we want this time? What would be the probability that the card chosen would be a red card? Right, okay, would be a red card. Right. I'm not expecting you to count all those. We can go up, you can if you want. That's why I'm showing you them. So I'm going to go about this in a different way here. So probability of getting a red card. Probability of red. Right, favourable over total. So I'm going to go about this in a different manner here. Okay. I'm just looking at the types of suits I had here. How many suits are red and how many are black? Here, that's what I'm thinking of here. Right. Well, there's a total number of suits. We could see that there. 2 red and 2 black. Okay. Let's see that, and that's my little diagrams of them. Not brilliant, but we want red. So how many of red we're going to put on the top? Looks like there are 2 there. So that's like 1, 2 over 4. 2 over 4, sorry. 2 over 4. And can 2 over 4 be reduced as a fraction? I think so. 1 over 2. And I think that's okay. So you could have went the long way and counted all the cards. Yes, 26 are red out of the 52 total. 26 over 52 would indeed give you a half. Because I know you're clever. Right, that looks okay. Right, let's go for another one. Let's go and pick another card. Let's see. So what would be the probability that a card chosen would be a face card? Right, what do we mean by a face card? Probability of face. Favourite. That's it. We want a face card over the total. Right, face cards. Jack, Queen, King. Is that correct? Jack, Queen, King. Can you see it on the right hand side of each of the columns here? Jack, Queen, King. Right. So how many have I got here? Giving you a big clue. How many face cards have I got? Cards with faces. An ace is not a face. Even though ace rhymes with ace, it's not a face. Right, okay. So it looks like we get Jack, Queen, King from each. And so there's 3 of them there. We've got 4 suits. And 3 lots of 4 is going to give you 12. So it looks like we've got 12 face cards. Right, and you can see it there. Yep. 1, 2. Yep. Yep, definitely 12 there. So I'm coming back. And so the faces I've got is 12. That's going to go in the top. That's what I want to happen. That's a favourable outcome. So that's going to be my 12. Over my total, again 52. And can you simplify that fraction there? 12 over 52. What's going to get into them? 12, 52. 2 goes into both of them. Or 4 goes into both of them. Right. I just divided by 2. Because that's the number I spotted initially. Then I'm thinking 6 over 26. I think I can divide that by 2 again. So that's exactly what I'm going to do here. 26 goes 3 times. 2 into 26 goes 13 times. So that's 3 over 13. That's fine. I could have got that if I spotted that 4 went into both of them at the 12 over 52 line. So it looks like probability of getting a face card is 3 over 13 or a 3 in a 13 chance. I think I'm okay with that. Yep, I'm definitely okay with that. Right, okay. So let's think. So I just want to point something out to you here. If I can find it. I can find it. Right. Just bear with me, bear with me. Yes. You know, it's here. Tossing a coin, throwing dice, cards on the right, roulette. You might think that they're all related to gambling. Well, you would be right, but I'm putting up a little disclaimer here. Okay? A disclaimer means don't blame me. Okay? And that's saying we're not advocating or encourage you to gamble. Okay? Gambling is usually for money or for other things. Thing is, with probability, the easiest way to learn it is by looking at games of chance. Because we don't know if we're going to pick an ace or a king when we select a card. We don't know, it's only a prediction. But to learn the rules, it's easy to see with these games because there's two sides in the coin, 6 faces on a dice that we specified, 52 packs in a card. Once we've learned those kind of basic rules, then we can move on. And like it's saying there, we use it in other fields, like in the sciences, the banking industry, engineering. It's all there. And the people, when you first go and learn this stuff, that's what they show you. So that was just, well, I'm saying that was short. That's over half an hour. So as I always say, you can always rewind this and see how you got on, and then go and try the exercises again, because they're not always as simple. It's talking about dice and cards, whatever. Just take you down. So if you're looking at this, you're probably maybe a member of one of my classes. So you can go through it. Oh, so it doesn't always have to be games of chance, right? It doesn't always have to be. So there's plenty of examples there. Right? And where else do they use probability? Well, believe it or not, you probably check this every day, or you hear someone talking about it every day. There you go. Weather forecast. Okay. You might see it in a newspaper. You might hear it on the radio. So the highlighted one, they're showing you it's a percentage. That percentage is based on recorded information. Okay. So a percentage here, 40% at 0.4, it definitely lies between 0 and 1. So just to finish on that note, folks, probability is not a certainty that something is going to happen. It's just to give you a guide, like a kind of a mathematical prediction that something might happen. Okay, that's what it is. It's not a definite. Right. So hopefully the weather will be good tomorrow. Right. So I'm going to finish there. I'm sorry for this taking so long, but it's for maybe it's for my benefit. I don't know, your benefit. Okay. Right. I'm going to finish here, and if you're seeing this, it means you've accessed it. Right. Okay. Right. Bye for now, folks. Good night. Night.